Ever wonder what the world is really made of? Well, welcome to our short video lesson on elements, atoms, and the numbers. Our objective for this video is for you to be able to define the atom and its structure, identify the mass of an atom, analyze an element on the periodic table, and apply understanding of concepts to find the number of protons, electrons, and neutrons in one atom of an element. What are elements? Elements are pure substances that cannot be broken down. Some of these examples include lead, gold, and neon. Elements are the simplest naturally occurring substances found on Earth. Elements are, well, think about it this way. Everything you see is made up of an element or a combination of elements. The computer you're watching, the chair you're sitting in, the money in your pocket, and even you. Yes, you're made of elements as well. So, there are 118 elements that make up everything you see. Another way to think about this is by comparing it to the English language. There are many words I can create, like the ones on your screen right now. But no matter what, they're all still made from the original 26 letters. That's the same with elements. Everything you see comes from the 118 elements located on your periodic table. So one question you might have now is, where can I find a list of these elements, and maybe even how are they organized? Well, my friends, this, stallions, is what's known as the periodic table of elements. The periodic table organizes the elements in a particular way. A great deal of information about an element can be gathered from its position in the periodic table. For example, you can predict with good accuracy the physical and chemical properties of an element. You can also predict what other elements a particular element will react with chemically. We'll talk about organization of elements on the periodic table in a later video. In thinking about elements, eventually curiosity brings you to the question of, what are elements made of? And the answer to that would be atoms. Like the one posted on your screen. Atoms are the basic unit of chemical elements. Groups of the same atoms make up elements. So groups of carbon atoms make up the element carbon. They are also the source of atomic energy. Ever heard of an atomic bomb or a nuclear power plant? Atoms of different elements have a different number called the atomic number. Atoms themselves are made from three distinct particles. In the nucleus or the center of the atom, you can find protons, which are particles with a positive charge. Protons help identify the atom and could be considered as the atom's DNA. Protons are equal to the atomic number of the atom and contribute to the atomic mass. It is important to note that the number of protons is also equal to the number of electrons. You will also find in the nucleus neutrons, which are particles with no charge but also contribute to the atomic mass. Lastly, electrons, which are particles with negative charges, can also be found on the outside of the nucleus on what we call the shell. Electrons move so rapidly around the nucleus that they create what is called an electronic cloud. The mass of electrons is insignificant or very small when compared to protons and neutrons, and therefore has no bearing on the atomic mass of the atom. Again, don't forget that the electrons are equal to the number of protons, and they are involved in the formation of chemical bonds. To determine the number of particles, we need to refer back to our periodic table. The periodic table, along with a few calculations, will give us specific information about each element and its subparticles. Each square on the table identifies a different element. This one identifies the element helium. Within each square, you will find the element symbol, the atomic mass, and its atomic number. The atomic number, almost always the smaller of the two numbers found on the periodic table for each element. In this example, the atomic number 2 can be found at the top of the square. The atomic number is sometimes called the proton number because it is equal to the number of protons found in the nucleus of every atom of that element. So for this example of helium, we know that there are 2 protons in every atom of helium. The atomic mass in neutral elements, which we will get to later, is equal to the sum of the number of protons plus the number of neutrons for that element's atoms. Electrons are not a part of the atomic mass. Now let's practice applying some of the concepts we just learned to use the periodic table to find the number of protons, neutrons, and electrons in different elements. Alright, so let's try this, right? Two things to remember is that A, the top number, usually the smallest number, is also the same as your atomic number. And then B, that bottom number, usually the larger of the two numbers, is going to be your atomic mass. So you'll also need to remember that your atomic number is also equal to the number of protons found in your nucleus. The second point that you'll have to remember when trying to find the number of protons, electrons, and neutrons in a given atom using the periodic table is that the number of electrons is going to be equal to the number of protons in a neutral atom. There are other types of atoms in which this is not the case, but we'll discuss that at a later video. The third point that you will need to remember when trying to use the periodic table to find the number of protons, neutrons, and electrons in a given atom is that the atomic mass, again, the number that is the larger of the two, is a combination of both the number of protons and the number of neutrons. So let's begin by searching for first the number of protons. So remembering that the atomic number is equal to the number of protons, if we find the atomic number, we can also find the number of protons. So let's identify the atomic number. Again, it's usually the smaller of the two listed. And so if our atomic number is 3, then our protons must also equal 3. Now that we found the number of protons, let's now try to get the number of electrons in a lithium atom. Finding the number of electrons is pretty simple. Remembering that the number of electrons is equal to the number of protons in a neutral atom, if we found the number of protons, then we've also found the number of electrons. So, if we have 3 protons in one atom of lithium, then we must also have 3 electrons in one atom of lithium. Now for the neutrons. This is probably the most challenging of the 3. To find the number of neutrons, we must reference the atomic mass. When you find the atomic mass, you will find that on some periodic tables this number is not always whole, in which case you will need to round to the nearest whole number. Lithium, with its atomic mass of 6.94, will be rounded to 7. Lastly, remembering that the atomic mass is a sum of both the number of protons and the number of neutrons, we will have to apply a little bit of math in order to find out how many neutrons there are. What we'll do is subtract the number of protons from one side of the equation, giving us the number of neutrons by itself, and then do the same to the other side of the equation. So atomic mass minus the number of protons will give us the number of neutrons. 7 minus 3 gives us 4. There are 4 neutrons in one atom of lithium.